Hi guys, good afternoon. So in the last session, we went with the DHCP protocol. We saw about DHCP, DHCP server, DHCP client, and also we saw about the messages. Okay, so how many messages we saw? 8 messages we saw. Okay, what are those 8 messages? We have okay, offer, request, acknowledgement, then decline,
Release.
release, and inform.
Info.
So if we talk about DHCP discover message, who sends it? First of all, sent by client. Why? In order to discover IP address. In order to discover DHCP server or servers in the network, right? And this message is what? Broadcast. Broadcast. Offer sent by server, right? And this one is sent in response to DHCP discover. Okay, what it contains? You can say next free IP address or offered IP address and other parameters, right? Other IP parameters. And this one, depending on the OS, it is unicast or broadcast, right? Then request message. Who sends it? Sent by client. Then this message shows the acceptance of IP address. IP address offered by the server. Okay. And this is a broadcast. This message is a broadcast. Acknowledgement sent by server. Okay. This message acknowledge or confirm the client that now they can use the offered IP address. Okay. What about decline message? Sent by clients. Why client sends the decline message? There is a duplication of the IP address. That means the IP address sent to inform server about the duplication of offered IP address. That means whatever the IP address server has offered, that IP address already exists in the network, right? What about release? Again, sent by client. Okay. Sent when the client voluntarily releases the IP address before expiry of lease time. What about negative acknowledgement? When the negative acknowledgement is sent, first of all, sent by the server. Okay. Sent when the IP requested by the client is not available, or you can say free. Okay. What about inform? Who sends it? Client, right? Sent by the client to request more information or parameters from the server. Or you can say to request missing parameters from the server, right? Oh. Now, DHCP relay agent, right? Notice this one. Clear this. I think this is already there in the document that I have shared, right? Okay. Now today let's discuss about relay. DHCP relay agent. Now, what is this DHCP relay agent? So yesterday we have seen about the definition that this is a node that is responsible for facilitating the IP address assignment and for exchange of DHCP messages between the server and client when they are not present on the same network, right? So when your DHCP server is not present in the same network, in that case, your relay agent is used. Okay. So let's consider a scenario. I have a router. Then I have a server this side, which is my DHCP server. Then I have a switch. Then I have few clients. So this is my DHCP server. This is my gateway. This is switch. Then we have PC1 and we have PC2. Okay. Consider this is our Z0 by 0 interface. This one is Z0 by 1 interface. Where is the system sound coming from? This is, let's say, F0 by 1. Then we have 0 by 2, 0 by 3. Okay. This side, we are using the network for an example 192.168, let's say 1.0/24. The sound is coming from classroom or somewhere else? Outside? No, that is different. That is different. Some sort of leakage or something. Okay. This is 192.168.1 dot, let's say 100, which is our DHCP server IP address. This is, let's say, 1.1. Here we have, let's say, 10.1.1.1. Okay. Now, in general, what will happen? That, let's say, this client wants to receive an IP address. So this client is going to send a discover message, and discover message is a broadcast. So how a switch deals with the broadcast message? Hmm? How? How a switch deals with the broadcast? Hmm? All the ports? Sure. Hmm? Except the port it was received on. Okay. So that means this broadcast message will be sent to F0 by 3 also, as well as
F0 by 1.
F0 by 1 as well. Right? Now, will the router forward this message on the interface Z0 by 0? No. Why? Because this is a broadcast message, and a broadcast message never leaves a broadcast domain. Broadcast message never leaves a broadcast domain. And second thing, router divides the broadcast domain. Each interface of a router is a broadcast domain. Router has per port broadcast domain, right? Yeah. So that means this message cannot travel on this side. Not possible. So if this is not possible, will this PC ever get a DHCP offer message? Mhm. If there is no DHCP offer, will the client ever get an IP address? No. There will be no IP address provided to the client. Then how they will get the IP address? We need something, we need to somehow forward this DHCP message to the server. And for this reason, what we use? Relay agent. Correct? Okay. So need to configure what? DHCP relay agent. How do we configure the DHCP relay agent? So let's say this gateway I have to configure it as a relay agent. So how I'll configure here? Tell me. Okay, interface Z 0 or 1? 0 by 0. 0 or 1? Hmm? Why 1? Why 1? Okay, good. Where the message is arriving? Z0 by 1. The discover message is arriving on Z0 by 1. And we know that, okay, router will never forward it to Z0 by 0. So there is no point on configuring relay agent on Z0 by 0. Always on the client side interface, you will be configuring, right? So this will be Z0 by 1. Then you will say IP, helper address, then IP address of the DHCP server, which is 1.100. Okay, let's say I have configured this thing. Now, what difference does it make? It will convert that broadcast into a unicast message. Okay, it will convert the broadcast into. How many of you agree? Hmm? How many of you agree to this? That this broadcast will convert it into unicast. Hmm? Hmm? It will generate unicast. Okay. Let's do one thing. What I'm going to do is I'm going to mention MAC addresses. Let's say this is PC1 as the MAC address M1. This interface here, this is M2. This one, M3. And let's say the server has something like M4. Okay. So when this PC will generate a DHCP discover message, the message contents will be, we know that, okay, there is going to be source IP, destination IP, source MAC, destination MAC, right? Yes or no? Okay. Then what will be the source IP? Hmm? PC is generating, right? What will be the source IP? Unknown. PC doesn't have an IP address. My PC doesn't have a IP address. So this will be 0.0.0.0. What will be the destination IP? This is a broadcast message. PC also doesn't know where is the server. That's why it is sending what? DHCP discover message. So this will be 4 times 255. What is the source MAC address? M1. Destination MAC? FF, because this is a broadcast message. This is the message. This message will travel. This is the DHCP discover message, right? And this is the DHCP discover message. Now this message came to the gateway on the interface Z0x1. And you have configured relay agent. Now what will happen? How this message will be forwarded? Destination IP 190.168.100 and source if you have 190.168.100 and destination map. Okay. So this is the broadcast message that is coming from the PC1, right? And you are telling me that, okay, this is going to be unicast. Router will convert it into unicast. Let's see. So what will be the source IP? Is it? How do you know? Have you seen it? Hmm? Have you seen? Or just a guess? You practiced this, right? This topic was there. In your CCNA relay agent was explained, right? Practically shown also. Yes or no? Yes or no? Looking like I'm teaching rocket science, huh? Was there or not? Was there? Studied? No idea. When was your CCNA? Long back. Still going on. Relay agent not discussed. Okay. Anybody who has completed CCNA?
So in our class also relay agent was not discussed.
Or is it
I had done it in last September actually.
last September?
Yeah, 2024.
Not done? Don't remember. Done or not? Done. Practiced. Hmm? Sorry. Yes. Was there or not? There. Studied. Hmm? Forgot. Well done. Okay. So definitely your DHCP relay agent, that means the gateway, will convert it into a unicast. It is going to convert it into a unicast. But it will not use this IP. Why? Because I didn't configure relay agent on this interface. I configured relay agent on which interface? Z0 by 1. So the same interface IP will be used. Same interface IP will be used. Because you might have noticed that whenever you are configuring this, right, as a relay agent, you need to have a either default gateway or a default route on this server. You need to have a default route or a default gateway on this server. Otherwise, you will not get an IP address. Why? If you use this IP, it is the local network. The communication should be there, right? But actually, the source IP is this one, a different network. That is the case. Just simply remember that whatever the interface you configured, relay agent, same interface IP will be used as a source IP. As simple as that. Okay. So 10.1.1.1, then destination IP. So definitely it will be sent to the server, which is then source MAC address. What will be the source MAC address? What will be the source MAC address? M2 or M3? Hmm? M2 or M3? Hmm? M2 or M3? How many of you say M2? Hmm. Then we will go with M3. Okay. So this will be M3. Right? Correct. Then destination MAC. Destination MAC will be M4. Correct. Okay. Now, this is the unicast message that is going to travel to. Now a mistake. Need to generate again. Source IP, destination IP, source MAC, and destination. 192.168, 1.1. Don't worry, we will verify once we are doing the practical. Okay. So this message will travel from the gateway to server. Okay. And then server will respond as a unicast to the gateway, and gateway will generate a broadcast segment. This is how the exchange will be facilitated. Clear? Understood? Right? Let's do it practically. So on this router, I'll change the MAC addresses so that it will be easier for us to track. We'll see if it will use which interface MAC address. Here we will use. Okay. This is our DHCP server. And this is our gateway. Now here, I'll configure the DHCP and everything. Interface gig 0/0 IP address. No shutdown. IP DHCP pool CCNP. Default router. DNS server. Done. Excluded address, and I'll reserve only one address. Done. DHCP also configured here. Now let's go and configure this one. Interface gig 0/0 IP address MAC address interface gig 0/1 IP address no right. So now I should get the IP address in the clients. Yes or no? I didn't configure helper address yet, right? So let's go and take a look. First of all, let me go and capture the Z0/0 interface. so that we can see. Okay, I'll configure I'll capture Z0 by 0 interface, as well as I'll also capture this is Z0 by 0 capture. Let's also capture Z0 by 1. We just want to see that, okay, without DHCP helper configuration, whether the router will forward the traffic or not. Okay. So as of now, if you see, I'm already getting DHCP discover messages. From where I'm getting these messages? Windows machine, right? It can be Windows machine, or also it can be my router. Because when you do not say no until you say no in the router also sends the DHCP discover, right? Okay. But these DHCP messages are not coming on the Z0 by 1 interface as of now. These messages, they are not coming up on the Z0 by 1 interface. Okay, we can see here. Okay, so these messages are not coming on this side. We don't have any DHCP message. Okay, and if I filter DHCP, no DHCP message this side. And this side, we are having some DHCP messages. Okay. All right. Now let's go and configure the relay agent. So on the gateway, client side interface is what? Z0 by 0, where I have configured this IP. Correct. So I'll say interface gig 0/0, and then I'll say IP helper address. And what will be the address of my server? 10.100. Let's see. Now what happens? Now I should get some DHCP messages on this side also. I got it. See here. And if you see, what is the source MAC address here? 2222. And what is the source IP? That means IP is for this interface, MAC address is for this interface. Always remember, your MAC address never travels outside the network. Your MAC address does not travel outside the network. That is the reason that it can use this IP address, but it will use the MAC address for this interface on. Okay, so that means this one is correct. We use 10.111 and MAC address. Okay. Now if you see, I'm getting DHCP discover only this side also. On my Z0 by 1 interface also, I'm getting DHCP discover only. Why I'm not getting the offer? Why I'm not getting the offer? Because that is router and we don't have a route to this network. Exactly. Because the source IP in the discover message is what? 10.111, right? From here, the router is forwarding the DHCP discover here as a unicast. Okay. And in the unicast source IP is 10.111. So this guy doesn't know how to reach 10.111. If you take a look in the routing table of this guy, please show IP route. Do I have a route to reach the 10 network? No, I don't know how to reach. If I don't know how to reach, can I communicate? No, I cannot communicate. Another way, I can go here, debug IP packet. Let's see what do we get. Do you see what it says? There is a packet that is going from source 10.100 destination 10.111, and what it says? The packet is unrouted. The information is not present in my routing table. So what I need to do? I need to give a route here. I need to give a route. So either I can give a static route or else I can give a default route. Okay. And as soon as I'll start giving a default route, see here, IP route. Okay, and 10.1. This is the route I have given. And now you see it is sending. Instead of saying unroutable, what it says? Sending. Okay. Or I can say debug IP DHCP. Let's see if this is available. Okay. See here. Sending notification of discover. Okay. And see whatever the options are not available, it will say no option 125, option 125 not present in the masses. And then if it receives a DHCP discover. So DHCP discover received from this client through the relay agent 10111. Okay. So like this, it will have the information. Then what it says, sending DHCP offer to the client. Okay. This is sending the offer and it is saying that, okay, I'll be giving you this 10112 IP. Clear? And if there is a previous binding, because every time this will keep on sending the DHCP discover and server is giving offers. So server says that, okay, I have found a previous server binding also. That means in my binding table, there might be an entry. Okay. So like that. This is clear. Again, see DHCP discover receive. Okay. Now let me go and just say no to that router so that it will stop sending the DHCP discover. Here, if I will say no, now it will not send the DHCP discover. Okay. And now we will request the IP from a different person. Let's say this VPC, we will take the IP from, because we want to see the 4 message exchange. So if I say show IP, nothing. Now I will say IP DHCP and now take a look. DHCP discover received from this client through the relay agent bus. Then it will check that is there any specified pool. If there is a pool, then allocate the address without the class information and see here what is the address it is trying to assign. 10.115. Okay. So like this, it is going to assign the addresses. Okay. DHCP discover is there, offer is there. Okay. All these messages. Clear? And then finally it sent what? DHCP acknowledgement to the client, this one, 10.115, setting on the requested parameters. Okay. So this is how it works. Clear? So as a relay agent, it will use the IP address of your client-side interface. Okay. IP address of this interface. This is the IP that will be used. And this is the MAC address that will be used. This is unicast from gateway to server. Okay. And this is broadcast from client to gateway. This is how your DHCP relay agent functions. Any doubt? Anyone? Somebody sleeping? Tell them good morning. Good morning. Hmm? This is after lunch session, so I can understand. Yes, Hitesh. Okay. So relay agent is clear. Now next thing we have to start with the routing, right? Before starting with the routing, first thing we need to know what is a router. What is a router? Device. Device that
A device that helps to connect between two different networks.
connect between two different provides communication, right?
Yeah.
Router is going to do what? Going to provide communication between different networks. This is
Yeah,
one,
yeah, sorry. I mean communication between the different networks.
right? So number one, it will provide communication between different networks. Number two, what else? Okay, divide broadcast domain. Something important is still missing. That is also okay. What else? Number one, L3 device, right? Provides communication between different networks. What else? You say per port, collision domain. Then per port, broadcast domain. What else? Hmm? Intelligent device. Yes. Okay. Then what else? Hmm?
Full duplex.
Best path. This is the important point. Hmm. Okay. Next forwarding decision based on destination IP address. Okay. Responsible for finding for data transmission. This is why it is known as a router, right? Somebody who drives, what do you call them? Driver. Somebody who is finding a route for you. Router. right? Okay, that is a router. What is a route? Hmm? It is the best path to reach the destination. Okay. What is the routing table? Hmm? Table used to collection of best routes, right? It's a collection of best route itself is the best. Okay. What is the routing protocol? Hmm? Help us to determine the. Okay. So in interview, will you explain like this? How will you explain routing protocol? That statement is okay, best path, but there is a way to deliver. And you say help us. Hmm. That does something. Yes. Not. Okay. Anybody else? No? Yes. Protocols that are used to find the best path. Okay. All are right. Okay. Routing protocols. These are the protocols that helps the router. First of all, doesn't help us, right? These helps the router to decide the best physical path for data transmission. Simple. Okay. So you can say that these are the protocols that helps a router to find the best physical path for data transmission. Okay. What are routed protocols? Contains actual data within a data. Hmm. What are routed protocols? What are routed protocols? Distance. Routed protocols are the protocols which carry the actual information, actual data. Okay. These are the protocols that carry the actual data. Example, IP, IPX, Apple Talk. All these are what? Routed protocols. Okay. You can take as a IP example. Okay. While I was asking about routing protocol, we came across a word. What is a method? Method. What is a method? What is a matrix? I'm not asking examples. Hmm? What is a metric? It is a cost. What is a cost? It is a metric. Hmm? What is metric? Anyone? What is metric? Hmm? What is it? You studied routing in the CCNA, right? Was there? Metric also was there. You compared the metric, then you decide the best. Yes. Calculation done to find unit deciding the best route. Okay, in what case metric is used? In what case metric is used? Okay, then when this thing is used? In what case this is used? Okay. Okay, what is prefix length? Okay, in that case, administrative distance is used. What do you mean same prefix length? If I have configured one network, that means it will remain always same. Hmm? Correct. Administrative distance is a tiebreaker for a protocols. When you have multiple protocols configured on a router, in that case, administrative distance is used as a tiebreaker. But if you have a single protocol and single protocol is coming up with multiple routes to the destination, for reaching from source to destination, there can be multiple possible routes for the same protocol also. So when you're defining or when your administrative distance is same, AD for a protocol will be same only, but you have multiple paths to reach the destination. So when you want to compare between the paths, you use metric. Clear? So how to define them? You define metric as a numeric value that is used to decide the best path when more than one path is available to reach the destination. Metric is a numerical value only, right? So when you have more than one route, more than one path to reach the destination, what will be used? Metric will be used. Okay. What about administrative distance? What is it? Truth. Trustworthiness. Yeah, I was like truth and lies. What is going on? You can say it is the trustworthiness. of a route. Okay, it is a numeric value assigned to all the protocols that helps a router to prioritize a protocol when more than one protocol is configured on the router. When more than one protocol is configured, a router has to prioritize one. There was a situation with us also. When we completed our secondary schools, like 10th standard, we had an option. We can go with arts, commerce, science. And some people will say you go with arts and prepare for government exams. Some people would say you take commerce, you'll become CA, good money, right? Then some people will say take science and you'll become a doctor or engineer. Then everybody will say a different thing, right? But we have to select only one because your career can go on only a single path. Same way, router can also forward the traffic using a single protocol, single path. So that's why when multiple protocols are there, administrative distance is the tiebreaker. And if for a single protocol, multiple routes are there, metric is the tiebreaker. Clear? What if the metric is also same? AD is also same, metric is also same. Now what? Hmm? What will happen? Load balancing will happen. What will happen? Load balancing will happen. Right? So load balancing. What is load balancing? Dividing the traffic. Equally dividing the traffic. Okay. So load balancing is good or bad? How many of you say good? Hmm? Is it good or bad? Think about it. Load balancing is good or bad? Hmm? You think? See, your router can load balance depending on, okay. Your router can perform load balancing depending on destination IP, and there is one more parameter. Okay. Let me check. Okay. So load balancing, your router can perform load balancing, first of all, based on destination. Okay. And according to per packet also. That means sometimes router can say that, okay, traffic to a specific IP will go through one particular link and for other IP will go through a particular link. That is one type. Second type is per packet. That means one packet on the first link, second packet on the second link. Then third packet on the first link, again fourth packet on the second link. Okay. So these are the ways router will do the load balancing, either on based on the destination or per packet. Now tell me load balancing is good or bad. Topology what? Metric is same, AD is same protocol, same metric. Good or bad? Load balancing means what? Topology doesn't do anything there. Good only. Because if you want to retransmit few packets,
then we don't need to retransmit the whole how many packets. Like if there are 1,000 packets, only 500 packets need to be transmitted.
Why?
The rest 500 packets will be reached.
Why you need to retransmit first of all?
In case if we reach like, we have any issue.
What if I'm using the UDP protocol? Where is the retransmission? Load balancing. If your traffic is TCP, it's good. That means if you have a TCP traffic, your load balancing is good. But if you have a time sensitive traffic like voice traffic, video traffic, right? Any real time traffic, that means you can say UDP based traffic. Then what will happen? See, metric is same, AD is same. Did I say latency will be same? No, one of the link might be slower. One of the link might be slower. Maybe high traffic, latency, quality of service, XYZ things can be there. So in that case, load balancing is not good. In that scenario, load balancing is not good. So it depends on the traffic, not on the topology. For TCP based traffic, it's good. For UDP based traffic, not good. Clear? Okay. So if we talk about administrative distance, we know that different protocols have a different administrative distance. Can I change it? Like for WIP protocol, what is the value? 90? Huh? 120? Can I change it? How? How I can change? Okay, first let's go with the default. So let's say on one side we have protocol. On the other side we have in short AD. Okay. First of all, directly connected. What is the AD? 0, 1 or half? Then for static, for default, 2. Also 1. Why? Because static and default. Default is just a special case. Okay. Then RIP directly. AGRP. AGRP is 90. This is for internal. External is 17. Looks like you're good in routing. Then what about IGRP? It is 100. Okay. Then OSPF 110. Then BGP, ISIS. Okay, how much? 115. Then AGRP again. See, verify. I don't know these things. Okay. So if I make a mistake, do tell me. AGRP external. 170. Then BGP internal 200. Then what about BGP external? So this should come here, right? VGP, or simply say eVGP. This is 20, and this is IDGP. Correct, right? You guys are checking? Okay, then that's it. That's all. Unknown. So, anything else? Now you guys tell me about this one. I will ask you one more. Hmm? Okay, so now somebody wrote how much? Hmm? 5? Can you see that? Anywhere visible? Hmm? You studied 5. Have you seen it 5? Hmm? Okay. AD value 5. This is for AGRP. Summary route. Sure. Guys, Google it. I don't know. Hmm? Is it right? You have studied in CCIE, CCNA. Hmm? You have never seen. Is it correct? Checked? Verified? Okay. What about AD value 254? This one also check on Google. Although I'll show you practically all these things. Google it. AD value 254. Exactly. It is reserved for default route via DHCP. And AD value 5? Did you check it? Hmm? Now these few things are there which are not visible. Like these things you can see in the routing table. Can you see this one? Connected 0. Okay, so these few things like connected route, AD5 for your EIGRP summary route. Okay, AD254, which is for, uh, basically DHCP default route. Okay, these are not visible. Normally these are not visible, but I will show you. Okay. Now, next question. Everybody understands router. Everybody knows about router. What a router does? Routing. Correct. What a router does? Okay. Now, my question is, why router is capable of doing the route? Why router is able to route the traffic from one network to another network? Hmm? Sorry, intermediate device. Why you are able to execute the command IP route, router EIGRP, router OSP? Why you are able to execute all these commands? Let's say, hmm? Layer 3. Like this is the router, right? And if I say show IP route, why do I see this routing table in the first place? So function is this. In some time you will say ask Cisco. Why router is capable of doing the routing? Like why I'm able to use this command, for example, router EIGRP, let's say one. Sorry. Router EIGRP. Why I'm able to use this command? Why? Question is why. These are present. I know. In L3 switch also these are present. So why router is capable of doing the routing? Actually, you know the reason actually. You know the reason. You know the reason you have used the commands, but maybe nobody asked you like this. Interviewer will also ask like this one. Switch stores the MAC. Okay, what if I don't want to see this routing table? Let's say I'll execute the show IP route command and I don't want to see the routing table. What can I do? You can see, right? When I say show IP route, it tells me about all these codes and everything, and it shows me routing table. But I don't want to see this. Disable routing. How? You are giving what command? That means what? That means what? The command IP routing is already present in L3 switch. In L3 switch, how do you enable routing? Using the command IP routing. So in router also the same command enables routing. If you remove that command, router also cannot perform routing. Router also cannot perform routing. See here, if I say no IP routing, now check, do show IP route. Where is the routing table? No routing table. Just try router EIGRP1, router OSPF 100. Sorry. Alright. Why router is capable of doing the routing? Because the command IP routing is executed by default. Clear? And the interesting part is, let's say if you give a command, if I say IP routing here, if I say IP routing, so whatever the configuration you do, where is that configuration available? In the running config in the RAM. Let's see. Do show run. Let me know if you can see this command. Anywhere do you see this command? The command is not visible. The command is not visible by. Clear? So the IP routing command is not visible, but still it is executed by default. Understood? Okay. Now what happens when I say no IP routing? Routing features disable. This is what we know. And when we teach about proxy arc, we say that, okay, you can use router as a PC. Correct? Let's see. See. no IP routing. As soon as I disable the routing, from my routing table, all my routes are getting deleted. From my routing table, all my routes are getting deleted. And do you see what it says? This is why we say you can use router as a, because as soon as you disable the routing, it starts behaving like a host. It starts behaving like a host. And then after you can provide default gateway, IP default gateway and the IP address. PC also has a default gateway on, right? Clear? If I say IP routing, see what happens. Now see, in the routing table, adding 10.110/24 via, what is this 0.0.0.0? Default route. If I see here, do show IP route, I have an entry for 10 network, right? Same thing it is adding here. But what is this? Now remember, when you say, when you study about IP addressing 0.0.0.0 not used anywhere, right? Then sometimes you say it is used in default route. Correct? It is also being used here. Now what is this? No idea. If you have a static route, if you take a look, let's say in here, we gave a static route. Show IP route, right? I gave a default route. So I have a network, I have a CIDR. After the via, what do I have? Next stop address. After the via, what I am having? Next stop address. So that means this is also what? My next stop address. Now, if next stop is 0.0.0.0, that means directly connected. This means what? Directly connected. And you could see here also, it is clearly telling you. And the AD value for connected is 0. Normally, this is not visible in your routing table. This is a directly connected route. It will show you like this only. It will never show you AD value and matrix. It will never show you like this AD value and matrix. But here you can see. What is the AD value? What is the matrix? Clear? This is how you can. Understood? So route has been added. Another route has been added. Then one more route has been added, which is /32. Why this is /32? Hmm? It shouldn't. Okay. So in my routing table, if I see I have routes with a C code and L code, what happens? What is local? Always you see connected route and local route. Connected route, that means what network is configured. Local means what IP is configured on the router or on the interface. So this is single IP, that's why it is 30. Okay. And you see here, change the mode from host mode to router mode. Here. Online people, any doubt? Guys, are you there?
Yes, sir.
Maybe high latency. Okay. So this is clear. Oh. Now let's say I need to configure a static route. Okay, first of all, let's talk about different types of routing. Route. Okay. Type of routing. How many types? Two types. What are the two types? Static and what about default? Default also three types. Sure. Default is also a special case of static only. So actually two, static and dynamic. Okay. What is the difference between static and dynamic? Destination. Okay. What is static? Manually one by one. Dynamic. Difference between static and dynamic. Okay. What else? IP address. Routes. Okay. Dynamic. So how dynamic is capable of doing it automatically? Don't you configure the protocol? Don't you configure the networks? Then how? What is the benefit? The network is not there, still it will send that packet to that network, but in dynamic, if some changes, it will remove that. Okay. Is that so? Dynamic uses protocols to find the best route. Okay, good. And static uses manual comments. See, static means fixed. Static means fixed. So that means here you have to manually add all the routes. You have to manually populate the routing table. Here you have to manually populate the routing table. While in case of dynamic, what will happen? Dynamic routing automatically exchanges the information. The network information they automatically exchange. And then they run algorithms over the information to calculate the best route. Okay. Is that clear? Second thing you can say whenever your networks are known, then you can use static. Whenever your networks are unknown, you can go with the dynamic. If you are using a small network, you can go with the static. If you are using a large network, you can go with dynamic. Yeah. Okay. So which one is more preferred? Why? More works. Instead of network, you better say topology. Okay. You should have proper knowledge about the topology. In static, we have chances of error. We might end up configuring loops. In static, we might end up configuring loops. So to avoid human errors and admin workload, okay, we can prefer dynamic. But still, if it is a small network like 2 routers, 3 routers, we can go with the static. More than that, we prefer dynamic one. Clear? Now, for the static only, we have a special case, which is about default. So default route is what? When we don't know the networks, or when you have a single path for forwarding the traffic. Okay, on one router, how many default routes you can configure? On one router, how many default routes you can configure? Depends on number of ports. That many default routes I can configure. Okay, let's say how many you should configure. How many default routes you should configure on a router? Okay, let me give you a scenario. I have a router, again a router, again a router. Then this side, let's say I have some network this side. This side also I have a network. Okay. This is R1, R2, R3. This side I have some network A. This side I have some network B. Okay. Here I have some network C. Here I have some network. Okay, on R1, how many default routes I should configure? One. On R3, on R2, two. Sure. I can configure two, right? Yes or no? One for network A and one for network B. I can configure. Everybody agrees? Why no? I want to configure that. Ambiguous. How? It's like unknown address if you find to like the next one will be R3 and another one will be R1. You can decide it because so what? So which way to send? Which way to send? Will I have, let's say if I configure two default routes on R2, will I have communication or not? Default route means traffic can be forwarded. Yes or no? No. I want to configure one default route this side and one default route this side. I can do that. Yes or no? Cannot do that. We can. Router will definitely accept it. And router will also forward the traffic. Will I have communication? I'll have communication. How seriously? Hmm?
First configuration is the first of the consider.
Who says? Default route, KD value will be 1, metric will be 0. That means same AD, same metric. What should happen? Load balancing. So that means communication will be there, but will not be 100% success. There will be packet drops. There will be packet. Clear? So that's why it is always suggested that on one router you configure only one default route. Best practices, if you want to configure a default route, configure it only one. There should not be more than one. Otherwise, you will not have proper communication. Clear? Okay. Now I have a task for you. Static, today you guys revise, tomorrow we will discuss. Because I need to ask a lot of questions. Okay. So your task is related to DHCP relay agent. Okay, this side you have network 10.1.10/24. Now here IP dot one. Here also dot one. Dot one. Dot two. Dot two. Dot two. Dot three. Dot three. Okay. This is only the DHCP server where all the pools you will configure. These clients, they should get IP from this network. These clients, they should get IP of this network. These clients, they should get IP of this network. This is your task. You'll configure it. Okay. Why to bother? I can ask online people to do the same thing. Online people take screenshot and drop it in the group. Okay. So this is your task for today. Don't ask ChatGPT for the configuration. Okay, do it yourself. Okay, so any doubt in today's part? No? Interesting? No? Informative? Not interesting. All right, guys, then I'll see you tomorrow. Have a good day. Bye.